Okay, welcome back. So we were talking about arrays, and soon we'll get into vectors, but let's continue with arrays. So they just hold a bunch of stuff, one after another, just like strings hold a bunch of characters. Arrays can hold things of any type. Could be int, could be character themselves. Yeah, so let's go to where we ended. We stopped with undefined behavior, which is a fun concept. And now that is ingrained in our minds. So let us remember everything about arrays. So the idea is, arrays, they hold a bunch of stuff, but it's of a certain type. That is probably the most key thing for you to remember. It could be any type that I put right here. It doesn't just have to be int. The array could hold whatever you want inside of it. And so I can make my array, it's just a variable name, make it be of size 3, and maybe it holds 1, 2, 3. And then suddenly in memory for me, what got made was a bunch of stuff, a bunch of ints, 3 ints to be precise, one after another. That's exactly what's going on in memory, okay? And so we have, maybe we're holding 1, 2, and 3 like we said, and these things exist at indices 0, 1, and 2. Remember that, just like for strings. So, yeah, arrays, they have a specific size, so you have to say what the size is, like I said, the 3 here. And that size cannot change later, all right? You cannot change it to be something else later. It is stuck being 3. There's not like an array at 3 here that does not exist, okay? Don't try and access it because it's undefined behavior, yeah? So yeah, just like for strings, these indices start at 0, and you can index into an array. That's the fancy technical term. You can index into an array with these bracket operators, so ARR at whatever index you want, call it I, and you can get and set the value, okay? So you can say equals something new. I don't know, ARR I plus 1. Or you could just get it to print it out. You could say cout ARR of j or something, assuming you had some index j. So all of these things are things that you can do with arrays, and they are wonderful, and you hold just a bunch of stuff one after another of any type. It could be int, it could be bool, it could be string, it could also be an array. Ho-ho. So let's pretend we wanted to store things not in a straight line, but in like a box form. Okay, so we got stuff along this axis and stuff along this axis, and only when we have a pair of things like index 1, 2 do we find what we're looking for. Okay, so that's what a multidimensional array is. So let's give you some examples of this. So let's pretend maybe we're storing an image. Images are 2-dimensional objects. They have a bunch of pixels in order. So we want 2 indices to store those pixels. We want to know what row we're on, and we want to know what column we're on. Yeah? That's the hope. So you can make an array with multiple indices like this, and it's called a multi-dimensional array. So here is what this might look like in memory if you say something like, if you wanted something like this. Well, let's just pretend that ints are colors, which they could be actually. You say int array 3, 3, and that makes a 3 by 3 array, okay? And in memory, it's going to look like this. So, dun dun dun, you've got indices 0, 1, and 2 on one axis, and 0, 1, and 2 on another axis. So you have 9 elements in total. So it's just like I drew down here. And you can set those individually. You could say array 2, 1 equals, I don't know, 42. And that would go to, this is like the first index, and this is like the second index. This would go to index 2, row 2, index 1, and they'd line up, and it would set this memory right here. Okay, it would set that to 42. And you can do this for all these different ones between ARR 00, 00, and ARR 22, okay, and everything in between. So that is a multi-dimensional array, which is fun to think about, and it kind of multiplies what you have what you have available. Because let's pretend we made this very long array, long multidimensional array, so long in 2 axes. How many elements do you get to access? Well, you can start at ARR 0, 0, make your way to, ARR 0, 0, like that. Use those 2 brackets, and then you can go to ARR 0, 1, and eventually you can get to like all the way to ARR 0 and then 83, right? That's the last one in the first row. And then this goes all the way down to, for 1, for 2, for 3, all the way down to ARR 41, 83. Yeah, it's always one less. 41, 83. So that is the last accessible element. And if you think about this long enough, well, you have 2 degrees of freedom. You can travel in each direction, 41 times in the rows, 84 times in the columns, 42 and 84, sorry, because it's 0 through 41 and 0 through 83. So you really have 42 times 84 accessible indices, or elements, if we want to call them those. Okay, so that is a multi-dimensional array. Very fun, very interesting, I think. And you can actually have 4D arrays, 5D arrays, 3D arrays, whatever you want. You could say int ARR, like 3, 4, 7, 9. You can do this. It's weird, but you can do it. And this is just how the world works in C++. Maybe I can give you a very quick example of multi-dimensional arrays in code. Okay, multi-dimensional. So, I'm going to make an array. 4, 4, how about? And then I'm going to set that thing to be int ARR of like 0, 3 is 42, ARR of 3, 2 is 41, things like that. And so now you can access on both axes. And then you can go and print them out. And that's about that. So now you can store things that make sense to be stored multidimensionally. And it keeps track of them. Okay, so that's multidimensional arrays. Fun to think about. Good for things like images. Okay. I've told you a lot of good things about arrays. Some bad things. There are more bad things. Okay, so if we think about this long enough, we can come up with a long list, and this is getting us transitioned to this thing called vectors. So first of all, with an array, you have no ability to change its size. You have to say immediately up front, the first time you say, I want this array, you have to say also what size you want that array to be. You have to give the size up front, and you cannot change it later. So you're stuck. You're stuck with whatever size you pick. Okay? And in general, and this will become apparent when we talk about functions, arrays have no clue what size they are. You have to remember that. Okay? The array itself does not know. Doesn't know where it stops. That is a bad NT apostrophe. Let me fix that. So this array has no clue where it ends, even though, like, you said somewhere how big it has to be. It just has no clue. And that's why you can do silly things like this, because it's not checking, because it doesn't know how big it is. Okay? So that's the idea. You can accidentally access past the end of it, or if you're trying to be really, really silly, before the end of it, before the beginning, I mean, and you wouldn't know it. Okay? You might not get a runtime error. You have no clue. So if only we could say, all right, my vector has, or my array, sorry, has this size, And, oh wait, I need one more thing. Let's make that one more thing. Shiny and new. I would like something like this, but that's not really happening, okay? It's not with arrays, but we can make this happen with vectors. Okay, we can solve all these problems with vectors, and so maybe that can be shining rainbow colors. So that is my lead-in to this next topic. Soon we will talk about vectors. Let's talk about arrays a little bit more, and then we will move on to their fancy sibling known as vectors. So I want to give you one example of swapping indices in an array, which is a very useful thing to want to do. So let's pretend I have my favorite array with 3 things in it, 1, 2, and 3 at indices. Remember, if only I could write a 3, 0, 1, and 2. Let's pretend I wanted to swap these elements right here. So like I wanted 3 to become this, 3 to be at index 0, and 1 to be at index 2. Yeah? Surely there's something simple I can do. I could just do something like ARR of, I don't know. Let me redraw this array just to show you what I'm about to do. 1, 2, 3. Surely I could just do something like this. I could say, okay, yeah, ARR of, well, we want to set 0 to be whatever was at index 2, so let's set array at index 0 to be array at index 2. Easy, right? And then I could be like, array at index 2 equals array at index 0, right? Right? And the answer is no, you cannot do that, because look what happens after this line. That sets array 0, so it sets this to be array 2. So it moves the 3 into here. And bam, look what happens right there. I just lost that 1 that I would like to put into here. So this line, array 2 equals array 0, well, it's putting 3 back into 3. There was no difference now because we just moved 3 there. Do you see the issue? You need to save. Key idea. You must save things that you're overwriting. What you're about to overwrite. If you want to use it ever again. So before we do this, before we get rid of this 1, we better save it somewhere. So we can do this. We can say, customarily it's called a temporary variable. So we say int temp equals array at index 0. And that will save over here in temp. I'll write it right here. Over here in temp, that's going to save the 1 on this line. Then we'll overwrite the 1 with the 3, but the 1's safely stored right here. And then we can say AR2 not equals AR0, but we can say equals temp. You see the beauty in that? That will correctly put the 1 here because temp is saving that 1. Okay, I hope you see that. That's the beauty in it. We want this temporary variable. That saves us right here. We need that there. And if you want to know the trick, like this seems like a very long, complicated thing to want to do, to just swap 2 indices in an array, there is a trick. Here is what I want you to notice. Look at temp and ARR0. Those start the whole thing off. Then, look at this. You see this pattern? ARR0 on the right side, then on the next line ARR0 on the left side. ARR2 is the one thing that's left. You have to put it there. And then suddenly it appears on the left side after being on the right side. And then finally it wraps around to temp, the first and the last thing. So you see this kind of like correspondence? Whee! Like that? That is how I want you to remember this. That's how you can swap 2 indices in an array. Okay? So I'll keep the temps highlighted. Let's code this up just quickly. Whee! Let's call it swapping. Whee! And let's make my array. I technically don't need this 3 because I gave the values, so it knows, C++ knows how to count. And so now let's swap indices 0 and 2 of ARR. So what we'll do is we'll say int temp equals ARR0. You could just as easily save ARR2 in temp and do this backwards. And then, oops, and you'll say ARR0, because they align. The thing that was on the right-hand side of the previous line is on the left-hand side of the next line, equals ARR2, and then ARR2 equals temp. Okay, and so now I can print the entire array out, maybe with spaces in between. And then we'll watch it work. So it should be not 1, 2, 3 anymore, but 3, 2, 1. What have I done wrong? Dun dun dun. It looks like, oh, I needed 2 arrows right there. Silly me. 3, 2, 1. Isn't that fun? So that is how you swap things. Just remember these 3 lines. That will be your incantation. That is how you magically make those things get swapped. Okay, so that is arrays. Now let's get into vectors. So these are going to actually be a lot similar, more similar to a string than an array. They're kind of like a weird combination of strings and arrays. So you can think of them like strings. And they make your life so easy. And I'm going to show you this reference page about them too. So let's just go there immediately. You can search for C++ vector, and it's going to be the first result. This is the vector header for C++. Okay, and here's all the stuff that's inside of it. And let us talk about all this stuff that you can do with vectors with several examples. Okay, so first things first, a vector, it's what's known as, the technical term for it is a dynamic array. And dynamic means like it can move around, which is very good for us. So its size can grow because there is a pushback function that works on a vector. There's a dot pushback function. Okay? And what that's going to do, push is a weird metaphor, it means to add to the end. Okay? And this is wonderful. You can use these brackets with a vector, just like you might with an array, but you can also use the .at function, which you know from strings already. And this will cause you to get a runtime error if you ever go past the end of a vector. It's going to stop you from doing silly things, which is wonderful. That's quite nice. So you can't do something like, it'll stop you. It'll like end the program. If you try to do something like cout vector v at index 4096, something huge, that will stop the program with a runtime error. The size function is wonderful because, vectors know their own size, not arrays, but vectors, they know their own size. You can set an initial size if you want. You don't have to, because you can just keep on adding to an empty vector with pushback. And you can give it initial elements just like you could with normal arrays. Okay, so let's have some demos now. Let's notice two different ways that we can make a vector hold 1, 2, 3, and that'll be that. So let's figure this out. Let's make a file called vectors.cpp, and if you want to use vectors, you have to include the vector header. So this says, now we can use vectors. It gives us the vector type. Okay, so now, instead of int arr bracket bracket equals 1, 2, 3, this is how you make a vector of integers. Okay, you kind of put the type in a weird spot. To make a vector of ints holding 1, 2, 3 in that order, you can do the following. Vector, the type first, if only I could spell, and then you say in between these angle brackets the type that goes inside. It's a vector of ints, and then you give it its name. So let's call it v, and then you can do just like you would do with arrays. Let's say 1, 2, 3. Okay, this is one way to make a vector that holds 1, 2, 3. Okay, so just like an array. Just like an array, almost. So that is one way to see a vector. That's not too bad. And then we can print out everything inside of it, just like this. We can use a for loop. We can go through every valid index in this vector. For int I equals 0, I is less than v.size, because it knows its size. The size happens to be 3, and we don't want to go all the way to 3. And then we'll say I++, and this will output the vector, v at I, and then a space, and then maybe a new line after all of that. So this is going to print out every element of the vector, okay? Go through every valid index of the vector, and print out the vector at that particular index, okay? Okay, so this is the regular way to go through the entire vector and just print everything out. Let's see if we can make this run. Let's see what it's complaining about. Let's see here. Oh, that's a warning. Are you ready? No, let's actually compile the correct thing. There we go. Hey, so we get 1, 2, 3, and so this is just a normal array-like thing. But let me show you the cool thing, because we can make a vector hold 1, 2, 3 in a different way using this pushback function. So let's look at the documentation for this. Oh man, is there this pushback method here? And what it does is it takes anything and it puts it at the end of your vector. So if you have a vector like this, you can push back to it whatever you want, and you can do that as many times as you would like. It just adds a new element to the end of the vector each time. The size gets increased by 1. Isn't that fun? So that's lovely. This means we can start an array out empty, or start a vector out empty. v2, if I just say semicolon, v2 is currently empty. So like I'll print out its size. Prove that to you. It's 0, but I can add things to it with pushback. I can say v2.pushback, the 1, the 2, oops, the 2, the 3. Yeah? So now the size is 3. Isn't that nice? So we can add things to the vector one at a time, no matter how many we need. We can always put them there, and then we can iterate through the vector, of course, as usual. But instead of v, we want v2. Whee. There we go. So we get back 1, 2, 3 again, but this is the snazzy vector-only way of doing things. Okay, so those are the 2 options that you have when you want to make a vector hold stuff. Isn't that nice? So that's the first example. Now let's have a second example where we get as many elements, infinity elements, if we had enough memory, from the user until they type -1. So they're just going to keep giving us stuff. Okay? We're going to say, okay, please input stuff to us, user. Okay, we'll give them 42. So our vector started out empty, now it's going to hold 42. Bam. Hey user, enter more stuff. 43. Oh, okay, I'll just add another thing to my vector. This is v. 43. Okay, enter another thing, user. 44. Ooh, sure, I'll just push it back. Now I have a size 3 vector. And we're just building it up one by one. And then we can give them, then we can say -1, I'm done, and that will stop our getting of elements from the user. And so you see that there's a bit of repetition going on here when we're asking the user for stuff and then pushing it back to the vector. And that should scream in your mind now, loop. So we'll use a loop to repeatedly ask for stuff. and then we'll stop the loop whenever the user types -1. Okay, and then maybe we'll just like display back all the stuff that the user gave us. Let's do that. Let us do this in this way. How about let us call it get a bunch of elements or something. Get elms. How about that? .cpp. There we go. So again, I want to use vectors, so I'm going to include the vector header, and I can start my vector of ints, because we're going to ask the user for ints. I can start out empty. So v is empty, and then we can just repeatedly add to it with whatever the user gives us. And so we just repeatedly, forever, possibly, we get a number from the user. So like int num, and we'll get it from the user. Be like cout enter number. Hey user, please do that for us. In that number, and then if it's ever -1, we're going to stop. But otherwise, if it's not -1, we're going to add the number to the vector, just like that. So we can say v.push back num. Yeah, that should work. And then, once we're done with it, we can, I guess, print it all out again. Let's go back here and steal this to print out the vector. Okay, so this should do it. We're just going to repeatedly, potentially forever, get a number from the user. If it's ever -1, that's when we stop. Otherwise, we're going to put it back on the end of this vector that starts out empty. And at the very end, we're going to print the entire thing back. So that's going to be everything that the user typed to us that got stored inside of v. Okay? Enter number 42, 43, 44, -1. And hey, those all ended up in our vector v via the pushback method. Okay, so that was fun. We have just learned about vectors, and hopefully you see how nice they are. They remember their size automatically. You can add to the end of them. The .at function makes it very, very clear when you're off the end. So if I say less than or equal to, and go off the end accidentally, 42, 43, 44, -1, bam, do we get a runtime error. Beautiful. That helps us to debug. Okay, so I've showed you the easy way, the normal array looking way, or not the easy way, just the way you already know how to go through a vector. I used a for loop and started int I equals 0, I is less than b.size, I plus plus. That's all well and good, but you can iterate through a vector, not an array. This is not for arrays. Maybe I should put this over here. Not arrays does not work for them, because a vector knows how big it is. What you can do instead is a fancy C++ version 11 and later thing, and this is exactly why we're doing standard equals C++ 17. We get the good stuff if we do our later versions of C++, because the default one, if you don't give this, it doesn't even give you this. It's not C++ 11 sometimes. Okay? The fancier way is using what's called a range-based for loop, which, if you've learned another language, maybe it'll look a bit familiar, but it's very nice. Let's get rid of that red there. Are you ready? So what it can do is this. You can say for, if you had your array, or if you had your vector, sorry, and it was 1, 2, 3, and it was a vector of ints, what you could do is say for int element, int elem or something, colon, and the colon I want you to read as in, for every element in v. That's all you have to put in these parentheses. Then you give your body, what do you want done for each element? Well, I don't know. Let's see out it. That is an M. So isn't that nice? Elem just tracks what the current element is in the vector. So it ranges through everything. So like elem, let's say, gets set to the current element of the vector, and it gets a chance to be every element, okay? Current element in V, and it gets advanced every iteration of the body. How do I want to say this? It is advanced after each body iteration. Okay, that is what I want to say there, and this is wonderful because you don't have to like do something weird like this and involve indices when you didn't ever really care about the index, you just cared about the values themselves. So what's going to happen is the first time you use this, it's going to set elem in the body of this loop to the 1, because that's the first thing, and then the next time it comes back and it goes through the body again because there's more stuff, it sets it to 2, then it sets it to 3 because those are the 3 values. Isn't that nice? That's a wonderful little feature of C++, and now you know about it. So instead of all this, instead of this right here, what we could do instead is, alternatively to the above, we could use a range-based for loop. And here's how you can do it. So you say for int elem in the vector v. Well, I would like to see out elem, please, and then a space, and then a new line after they've all been printed, just to make it all nice and pretty, and nothing will change at all. 42, 43, 44, 8, 6, 7, 5, 3, 0, 9, -1, and it goes through the entire array, setting elem to be 42 first, then 43, then 44. I think you see the idea, and the beauty of it, less typing on your end too, right? So that is a range-based for loop. Take advantage of it, because you're using C++ 17 in this class. Whee. Okay, so one more thing before we get to a fancy example, a more complicated example. Let's talk about sorting vectors and arrays, in fact. Here's how you do it. So there is another header in C++, it's a very nice one, it's called algorithm, which contains some algorithms for doing things, and one of which is sorting. Okay, it contains a sort function. So let's go to that. We can go to algorithm, I think it's in other, yes. Go over here. Algorithm, it's got a bunch of cool stuff, I encourage you to look at it. One of which is sort, right there. Sort elements in range. And what it takes is what's called first and last. And that is the beginning and ending location in memory of, not your program, of your vector / array. So where it starts, where it ends, okay? It needs to know that so that it can print out everything from the beginning to the end. Not too bad, I hope. Technically, the ending location is 1 past the end, but we don't need to get into that right now. So suffice it to say that if you have your v, let's make it out of order, like 2, 1, 3 or something. Here's its beginning. That's the first index. This is v.begin. We'll give you back the location in memory where v begins, and you can look up that as well if you're interested. We'll get to that later in the class. Where is that? There it is, begin. It's called an iterator. It goes to the first element, okay? And whereas begin was the first, end is past the end, 1 past the end, okay? So that's v begin, and then technically v.end is pointing right here. For reasons. It needs to know when it's done, right? So in order to sort a vector, here's all you have to know. And let's get rid of these red things while we're here. If you have a vector, all you have to do is say sort, and then the beginning location of the vector, and the ending location of the vector, just like that. After this one line, it has sorted it for you, because the sort function in algorithm is cool like that, and it does everything for you. Okay, so let's make a file called sorting. And we'll make a vector. So of course we're going to include vector 8675309, and let's have it sort this. So we'll say sort. We also need to include algorithm, of course. Okay. Some more. There we go. Sort v.begin. Give it the beginning location, and then you give it the ending location, v.end. Okay. And so this, now, after this line, now the array is sorted. Or now the vector is sorted. Now v is sorted. And we can go through it and print it out with our fancy range-based for loop. X in v, call it x every element, cout x, and then a space, and then cout a new line. So watch this print out v, but the sorted version of v. Hey, and so isn't that quite nice? 0, 3, 5, 6, 7, 8, 9. All right, hopefully you see that that's going to eventually be useful. It's quite hard to write a sorting function. You can read about it in your book how hard it is, especially a fast one. If you have an array, on the other hand, you have to do a bit of addition, which is weird to think about. So I'd be happy to explain this weird-looking syntax to you in office hours if you're curious. Like you're saying ARR but without any brackets and indices. What does that even mean? And then you're saying ARR plus a number? What's going on here, dude? So I promise you will learn about this later in the class, but it's just let it be weird right now. These give you back memory locations is all I really want to say. So here's how you do it. So if you have an array int ARR equals, I don't know, 1, 2, 1, 3, 5, -42, 7. How about? And we want to sort this. You'll say sort. Again, ARR by itself is the start. ARR plus its size, which is 1, 2, 3, 4, 5, 6, is the end. It's one past the end. Again, come to office hours if you're really curious, but otherwise that's what you do. And now we can print this out, and we are forced to use a non-range-based for loop because, sad day, arrays do not understand how big they are. So we have to tell them. For int I equals 0, I is less than 6, I plus plus, because we want it to go from index 0 to index 5. That's what you get when you have a size 6 array. Then we will cout array at index I and a space. And then a new line, of course. And this will have sorted, before we print this, it will have sorted the array from this to the sorted version of that, whatever that is. Definitely starts with -42. That's all I know. Okay, so either way, it works, and this is what you get back. Okay, so that is sorting arrays. You will eventually want to know how to do that. Okay, I promise you that. So now I'd like to get to a very fun example. It's a culmination of a lot of things in this class, and we are ready to learn about how to reverse the contents of a vector or an array. So we're going to just brainstorm on this slide. And then we'll come back in the next lecture and put it into code. So let's figure this out. Let's pretend we have some vector v, And we would like to, in place, remove, or not remove, but move all its elements around, shuffle them, so that they're backwards. So if it was 1, 2, 3, 4, didn't have to be, it could be anything. We want to transform that in place to be, instead, the vector 4, 3, 2, 1. That's what we would like, okay? So, take a second, maybe pause the video and think about, what would you do? How would you, what's a good strategy? Do you see one of going from this to this inside of itself? Really, it's going to be 4, 3, 2, 1, right? 4, 3, 2, 1, like that. Do you see how to move things around? Do you see where they need to go? So take a second, think about that. I will get some water. And I think you might notice the following. Well, where does the 1 need to go? That needs to go to the very end. Ooh, but that's where the 4 needs to go. Ooh, they swapped. Ooh. So there's swapping involved. And you'll notice that also works for the 2 and the 3. Those also need to get swapped to 3 and 2. Ooh, that's quite nice. Is that always true? If you try this enough, yes it is. So, which indices get swapped? Let's think about this. So this is index 0, 1, 2, 3. At least in this example, we were swapping index 0 and 3, and then 1 and 2, but we want to generalize this because maybe our array is size 33, 53. How does this generalize? We want to swap the first element, the 0th element, with the end, okay? We want to swap 0 and size. So v dot size, right? -1. We want to swap those. We want to swap 1 and v dot size. Not -1, but -2, right? And then if there are more, we would like to swap, I think you can see the pattern, we'd like to swap index 2 with v dot size -3. Yeah, we're always going 1 more to the left, and then 1 more to the right, swapping those, all those elements. So there's a pattern here. Do you see it? And that is the idea. So let's see if we can discover this pattern. Let's try a bigger array, or vector, however you want to think about it. This is v2. Let's have it have 5 things. 0, 1, 2, 3, and 4. Or it could be 1, 2, 3, 4, 5. Who cares? But this is nice because the indices are the same. This would like to become 4, 3, 2, 1, 0. And again, you're still swapping all the same things. You're swapping index 0 and index size -1, which is, in this case, 1, 2, 3, 4. So you're swapping those indices. Actually, to make it less confusing, I'm going to make these values not the same as the indices. That might be a little confusing. Sorry about that. Let's make it 1, 2, 3, 4, 5. So again, you're going to swap this one and this one, and then this one and this one. And technically, you can swap this one. It's going to be 2, and v.size -3 is still actually -1, -2, -3. It's still the same one. You're swapping it with itself. That actually works. But there's a question of when do you stop? When do you stop swapping? Because it's kind of useless to swap this guy with himself. We don't really want to do that. We'd like to stop there. So how in the world do we know when to stop? And then how do we generalize this? Those are the 2 main questions. And the idea is you can make this a variable. The index you're trying to swap could be a variable. It could be I, let's call it. Okay, so instead of all that, we can say swap I and v.size, not -I, but -I -1. You see that? Size minus I minus 1. Okay, that whole thing. Whee. I hope you see that. So that's the pattern. And then, when do you stop is the next question. I'd like to swap this one and then this one with these two, and then I'd like to stop at this. Similarly, I'd like to swap this one and this one with these two in this order, and then I want to stop, okay? Before I try and swap this one and some other weird thing over here, maybe. That wouldn't make sense. So, where's the stopping condition? It seems to be about halfway through. Halfway through. What in the world could that be? Maybe we can just stop stop swapping when I is equal to v dot size over 2, question mark? That might work. We can stop swapping when, in this case, it's going to be 4 over 2 is 2. So yeah, we don't want to swap anymore once we get here. We've already swapped it. We swap this one with this one and this one with this one, and then once we get to this I equals 2, we can swap, so we can stop, sorry. That makes sense. That might work. What about this one? We want to stop once we get to index 1 again. Once we finish swapping with this 2 element. So what's v dot size over 2 for this one? Because v dot size is 5. Well, again, it's 2, isn't it? Because it's integer division. So we're going to swap this one with this one with this one, but now I is 2, so we will stop. And we won't actually swap this one with anything. I think this is working, don't you? So that's where I want to leave you right now, scratching your head a little bit, hopefully. I want you to try and make sense of this in your mind before you come back in the next lecture, and then we'll talk about why this is all actually going to do the right thing. Okay, so think about all of this, and I will see you in the next lecture.